This equation requires you to know and understand the formula, the double angle formula, and which is sine 2 theta equals 2 sine theta cos theta. So in this expression, it asked us to rearrange it to look like this, and we should notice that this formula looks a lot like this formula, so they should be able to relate somehow. Let's see what happens. 30 sine 3x cos 3x. So in this case, let's angle equals 3x. So I'm going to sub that in, see what happens. So 30, so we'll get 30 sine angle cos angle. Now I'm gonna split this 30 off, so we get 30. Now 30 equals, because we want to get that 2 out the front. You know that 30 equals 15 times 2. So I mean we can rearrange this into 15 times 2 sine theta cos theta. And that's just equal to this. So we can substitute that in. So we get 15 sine 2 theta. But theta equals 3x. Therefore, the equation equals 15 sine 2 3x. So I get 15 sine 6x. That's for that equation. Now it asks to solve f of x for 0. Either answer in terms of pi. So we have f of x. I'm not sure which one I'm going to use. We want that to be equal to 0. Now, which one? So, I think this, so we're going to have to solve for both. So, we're going to do the first one, because that looks easiest. 30 sine 3x cos 3x. And we're going to divide by 30. So, we have 0 equals sine 3x cos 3x. And we're going to set usual for law and set each one of these to 0. So we'll have 0 equals sine 3x. And if you know from the unit circle, sine of x is just the y coordinate. When is the y coordinate 0? It's when it's 0 and pi. So sine of 0 equals 0, but also sine of pi equals 0, and sine of 2 pi equals 0. What's our range? We just check. Okay, so it's a pretty small range, only up until pi on 3. So this is probably all good. So we have these values. We have these values of angle. Was 0, pi, and 2 pi. And if we have three of the angle, then we're gonna have to divide these by 3. So we'll have 0, 0, 0, pi on 3, and 2 pi on 3. And I'm pretty sure that's too big, so it's not that one. So for sine of theta, 0 and pi on 3 give us f of x equals 0. But there's actually more to it. So we also need to figure out how the cos x applies. So over here, cos 3x equals 0. So when is cos x equal to 0? Well, if we have a unit circle, cos x equals 0 when the x coordinate is 0, when the x coordinate is 0, there and there. That is pi on 2, and that is 3 pi on 2. So we'll have here, we'll have x is equal to, the angle is equal to pi on 2, 3 pi on 2, but then 3 of the angle, and divided by 3 pi on 6, 3 pi on 6, and that will just be equal to pi on 2, which is pi on 2 is larger than pi on 3, so that one doesn't count, but this one does. But then we also have, I'm just going to check right here, we also have this equation, which might pop something out. So 0 equals 15 sine 6x, right? And 6x is pretty big, so it's going to have some like pretty small numbers, small angles in there. So we divide by 15, so 0 equals sine of x, sine of 6x. And we know that for here, angle will equal to 0 pi, 2 pi, 3 pi, 4 pi. Yeah, that's probably enough. And then we'll divide this by 6. So we'll get pi on 6, 2 pi on 6, 3 pi on 6. Okay, that's getting too big already. So that's getting, that'll be pi, this will be pi on 2. So we'll have pi on 6 and pi on 3. Is that too big? I think so. So that doesn't count. So all the angles that work, actually no. No, yeah, I want this pi on 3. So actually, this equation, I guess because it's all by itself, it gave us out pi on 6 and pi on 3. But the other two, when you separated them, gave them each one individually. So cos x gave us pi on 6, and sine 3x gave us pi on 3. So x in this case equals 0, pi on 6, and pi on 3.